Hello, welcome to 5.6 Inverse Trigonometric Functions Differentiation. Did you know that none of the 6 basic trig functions have inverses? And you may remember this from your pre-calculus part 2 days, Math 127 at Western Nevada College. You might find that a surprising statement, given your past experience with arc, cosine, arc, sine. You know it's on the calculator, it's got to have an inverse. Well, what did we talk about when we talked about inverse functions a couple of sections ago? We said an inverse function had to be one-to-one. And these aren't going to be one-to-one functions as they sit. So, if we look at them with a restricted domain, then we have a one-to-one function. That's what I'm showing here in this chart. So, the function arc sine is the inverse of sine. It also says sine to the -1 power on the calculator. If and only if the domain of the input here is -1 to 1, and which means the range, what it will produce is -pi/2 to pi/2. And this is the concept that really gets students still. I teach Math 127. I see the question come up all the time. They have a hard time seeing, wait a second, why is it -pi/2 to pi/2? Because we had to restrict the domain, and so it would be 1 to 1. That's the key to it. This is the sine function. We restrict its domain, and that domain is the range of the inverse function. So arc cosine, y equals arc cosine if and only if cosine of y equals x. And what we plug in, -1 to 1, and what here is produced is 0 to pi, and this is because it gives us this swath of values from 0 to pi. But it stays 1 to 1. We're not going to have any problems with a horizontal line test. Arctangent will work for tangent being restricted to -pi/2 to pi/2, not inclusive because tangent of pi/2 is infinity, tangent of -pi/2 is -infinity. Arc cotangent can be restricted from 0 to pi. Arc secant is going to be restricted for secant restricted from 0 to pi, and arc cosecant for cosecant be restricted from -pi/2 to pi/2. So let's look at some values first. Evaluate each expression without using a calculator. Arc sine of 0. That means sine of something gives us 0, and if we're talking from 0 to -pi/2 to pi/2, that something must be 0, because sine of 0 is 0. So arc sine of 0 equals 0. What about arc cosine of 0? I have too many s's there. Well, that's saying cosine of what equals 0 on the interval from 0 to pi, and that would be pi/2, because cosine of pi/2 is 0. So arc cosine of 0 is pi/2. How about arc cosine of -√3/2? Well, cosine of what gives us -√3/2, and we're talking about the interval from 0 to pi. So we're talking second quadrant, and the value must be 5pi/6. Cosine of 5pi/6 is -√3/2. So arc cosine of -√3/2 must be 5pi/6. Okay, properties of inverse trigonometric functions. If x is between -1 and 1 inclusive, and y is between -pi/2 and pi/2 inclusive, then sine of arc sine of x is x, and arc sine of y is y. If y is between -pi/2 and positive pi/2, but not inclusive, then tangent of arctangent of x is x, and arctangent of y is y. And if the absolute value of x is positive, is bigger than 1, bigger than or equal to 1, and y is between 0 and pi, and y is not equal to pi/2, then secant of arcsecant of x is x, and arcsecant of secant of y is y. They undo each other. So similar properties hold for the other trig functions, but these are the ones we're going to tend to use. The sine, arcsine, arctangent, arcsecant. Example 2 says, solve the equation for x. Arctangent of 2x plus 5 equals 1. So tangent of arctangent of 2x plus 5, no, minus 5, equals negative 1, tangent of negative 1. Now it's important to note, tangent of negative 1 is just a number. It's not a function now. That's just going to be, represents a number. So tangent and arctangent are going to cancel. So 2x minus 5 equals tangent of negative 1. 2x equals 5 plus tangent of negative 1. X equals 5 plus tangent of negative 1 over 2. That wasn't so bad. Let's go on to page 3 and example 3. These are kind of fun. I like doing these problems without a calculator. Now, when I talk about arc cosine of something, it's going to produce an angle. So we could say that arc cosine of square root of 2 over 2 would be some angle like theta, which means cosine of theta equals the square root of 2 over 2. This means, this is talking about a triangle. We can draw a little triangle here. Here's our theta. Its opposite, which is square root of 2, over adjacent, which is the 2, or so over hypotenuse, which is 2. And we can find the other side if we want. Call that a squared plus square root of 2 squared equals 2 squared. So a squared plus 2 equals 4. A squared equals 2. A would be the square root of 2 as well. Then therefore, tangent of that theta, this part is just our theta. This is tangent of arc cosine. That's saying tangent of theta, because we define that to be our theta. Is going to be opposite over adjacent, square root of 2 over 2, square root of 2, which is 1. So tangent of arc cosine of the square root of 2 over 2 is going to be 1. You could also have recognized that cosine of pi over 4 is square root of 2 over 2. Tangent of pi over 4 is 1. Now over here, there's not a standard one for us to memorize for sine of what is 5 over 13. But if we said arc sine of 5/13 is theta, then sine of theta would be 5/13. So we could call this whole part in here theta. If we had a triangle, here's our theta, and I drew this one wrong, didn't I? And no one said anything. You're probably worse shouting at the computer. This is our A here. Probably like, Jeff, you did it wrong. No, cosine's adjacent over hypotenuse. I'm sorry, I said it wrong. Now, sine is opposite, which is 5, over hypotenuse. Pythagorean theorem gets us the last side. Call this A. A squared plus 5 squared equals 13 squared. So A squared plus 25 equals 169. So A squared equals 144, and A must be 12. So this is 12 here. So the cosine of theta is opposite, is adjacent over hypotenuse. So that cosine of arc sine of 5/13 is 12 over 13. Okay, let's talk about derivatives of inverse trig functions. And we're going to focus on, we'll look at all of them, but we tend to focus on just 3, and you'll see why in just a moment. Okay, let u be a differentiable function of x. The derivative with respect to x of arc sine of u is u prime. The derivative of what's in here over the square root of 1 minus u squared. And the derivative with respect to x of arc cosine of u is negative u prime over the square root of 1 minus u squared. They look similar, don't they? They look very similar. But the arc cosine has a negative in it. So we don't really need to use both all the time. So if we're doing an antiderivative, for example, we'll tend to fall back to this one. Arc tangent, the derivative with respect to x of arc tangent of u, given that u is a function of x, is u prime over 1 plus u squared. And the derivative of, with respect to x of arc cotangent of u, is negative u prime over 1 plus u squared. Again, they are identical except for this negative, so we can just not worry about this when we're doing antiderivatives. And for arc secant of u, its derivative is going to be u prime over the absolute value of u times the square root of u squared minus 1. The derivative of arc cosecant of u is negative u prime over the absolute value of u times the square root of u squared minus 1. So, again, they're just opposites of each other. We tend to focus on these three. Moving on to page 4 and example 4. Find the derivative of the functions. Okay, so our first one, f prime of t is going to be the derivative of t squared. That's 2t over the square root of 1 minus t squared squared. It's u squared, so t squared squared. 2t over the square root of 1 minus t to the fourth. For b, f prime of x is going to be what? It's arc secant. So that's going to be the derivative of the stuff inside. That's just going to be 2 on top over the absolute value of 2x times the square root of 2x squared minus 1. That's 2 over the absolute value of 2x times the square root of 4x squared minus 1. You could divide those 2's out and it would be 1 over the absolute value of x times the square root of 4x squared minus 1. For c, h prime of x, we have a product rule, so we'll do x squared times this derivative, and the derivative of arc tangent is going to be 1 over x squared, 1 over 1 plus x squared, plus 2x times arc tangent of x. So that's x squared over 1 plus x squared plus 2x times arc tangent of x. And then for d, f of x is arc sine. I already have it there. Its derivative is going to be f prime of x. The derivative of arc sine is going to be negative 1, no, just positive 1, the derivative of x, over the square root of 1 minus x squared, plus the derivative of arc cosine. This one's negative 1 over the square root of 1 minus x squared, because the derivative of x is 1 and it had a negative with it. So 1 plus negative 1 is 0 over the square root of 1 minus x squared, which is 0. We're going to go on to example 5 now. It says differentiate y equals arc tangent of x plus x over 1 plus x squared. Okay, so the y prime is going to be 1 over 1 plus x squared plus, now we have a quotient rule, low d high, so it's 1 plus x squared times 1 minus x times high, so it's high d low, 2x all over 1 plus x squared squared. So 1 over 1 plus x squared plus x squared plus 1 minus 2x squared over 1 plus x squared squared. I'm going to have a common denominator here. X squared minus 2x squared is minus x squared plus 1 over 1 plus x squared squared. So we have 1 plus x squared over 1 plus x squared squared plus negative x squared plus 1 over 1 plus x squared squared. X squared minus x squared is nothing. 1 plus 1 is 2 over 1 plus x squared squared. Okay, feel free to pause if you need to. We're going to go on to our last page. Got 2 examples left to go. This is find any relative extrema of the function f of x equals arcsecant of x minus x. So, f prime of x is going to be, the derivative of arcsecant is going to be 1 over absolute value of x times the square root of x squared minus 1. And we have a minus 1 after that. We're going to set this equal to 0. 1 over the absolute value of x times the square root of x squared minus 1. Minus 1 equals 0. So 1 over the absolute value of x times the square root of x squared minus 1 equals 1. If I multiply both sides by the denominator, I have 1 equals the absolute value of x times the square root of x squared minus 1. That's multiplying both sides by this denominator. Or you can do cross multiplication, whatever works for you. So if I square both sides, I'd have 1 equals x squared times x squared minus 1. So 1 equals x to the 4th minus x squared. So we could say 0 equals x to the 4th minus x squared minus 1. And our zeros from this are going to be x equals plus or minus 1.272. So you can factor it down. You can do u substitution, say u equals x squared, or you can use your solver button in the calculator. I think that's a fine way to go. So our minimum is going to be at 1.272 comma negative 0.606, and the maximum will be at negative 1.272 comma 3.7474. I'm going to go on to the last problem then. Angular rate of change. An airplane flies at an altitude of 5 miles toward a point directly over an observer. Consider theta and x as shown. So here's the observer. Airplane's flying this way. Going to eventually be overhead of the observer. Here's our angle. It's 5 miles in the air. Write theta as a function of x. So this is x here, the distance the plane is, its ground position. So for A, tangent of theta equals x over 5 over x. So theta would be arctangent or tangent inverse of 5 over x. Or you could say that theta is cotangent inverse. Then part B says the speed of the plane is 400 miles per hour. Find d theta dt. Find d theta dt when x is 10 miles and x is 3 miles. So how's the angle changing? So for B, our d theta dt is going to be negative u prime. Now u is this x plus x over 5. Its derivative is 1/5 over 1 plus u squared. So that's x over 5 squared. Negative 1/5 over 1 plus x squared over 25. I forgot my dx dt. I'm going to multiply both sides. Well, that's going to be negative 1 over 5 over 1 plus x squared over 25 dx dt. I'm going to multiply top and bottom by 25. And that'll give us negative 5 over 25 plus x squared dx dt. It says the plane is going to 400 miles per hour, so that's our dx dt is going to be negative 400 because it's coming toward this person. Okay, let's see. For x being 10 miles away, our d theta dt, how the angle is changing, and as that gets closer, you're looking out there, it's going to be, angle's getting bigger and bigger and bigger. Dx dt is going to be negative 5 over plus 10 squared times negative 400. And that's going to be 16 radians per hour. For x being 3, our d theta dt is going to be negative 5 over 25 plus 9, or sorry, 3 squared is 9 times negative 400. And that's going to be 58.824 radians per hour. So as it gets closer, that angle is changing at a much greater rate. That'll do it for 5.6 inverse trig functions. I hope you enjoyed that. I hope you are understanding this. Let me know. Send me your questions. Thank you.